Thank you, guys. Can you all hear me okay? Great, perfect. All right, let's get started. Hi, I'm Tony. Thanks for having me here. This is very exciting. Um, this is my first time in Serbia, so I know about Serbia, obviously, but I didn't know much. So on my way here, the first thing I learned about Serbia is that if you're at a Serbian party, you always have rakia. So this is a terrible party. And I want to apologize because I didn't see any rakia up there. But hopefully you'll enjoy this talk and get something out of it. So today I'm going to talk about really modern data lake practices at Foursquare and really how we use it to build great data foundation and that powers our product. Yeah, so I'm going to talk about a little bit about me, the history about from transition to database systems to data lake, and talk about the state of our open table formats, and then what are kind of like the future industry trends in the data engineering world. So I started out my career as a data engineer, really building data pipelines, and then over time I transitioned to become a platform engineer. So if you really never heard about what a platform engineer is that I tell Vladi to write a Spark job in EMR serverless, not in EMR. That's really my job, which is easier because I'll just tell him what to do and he will do it, and then that's my job. Yeah, so really I think like when I first started out my career, we're really heavy into some of the old big data systems, and I have seen a lot of transition in the industry to using newer technology, and really changes our pattern of accessing and processing and leveraging data in modern data systems. Yeah, so really, if you take a look at this, there's been a lot of evolution in the industry for the past couple of decades. Really started out in 1996. Postgres is open source. How many of you have worked with Postgres in your job? So a lot of you. It's a project out of Berkeley, and really kind of like it's one of the earliest and still very successful database systems out there, and it's still very in a lot of production usage even today. And then 10 years later, Hadoop got open source from Google. This is still very exciting till today because I have a job now because of Google. So thanks Google. Yeah, and then another 10 years pass. You have systems like Snowflake that's really focusing on, hey, we have tons of data. How can we really just build great distributed systems to be able to work with data in a much easier fashion? And then the past couple of years, the industry is really converging into even newer technologies like Iceberg and Delta Lake. So these are open source projects, really exist as a data storage layer, sits on top of the data lake. So Iceberg is developed by Netflix. How many of you know Netflix is a big thing here? Yeah, okay. So it's good. Netflix is very big in the US. And then Delta is developed by Databricks and Apple. So really, if you think about like this trajectory and really kind of like just ignore the specific example of like the technology, there's like really the underlying philosophy or themes, what I call it, is like, what is really the problem that we're solving in the data industry? So really, when the database system first came out, even maybe before that, but like in the 90s, is that the idea is that we want to have very convenient access to structured data. Meaning if you're building websites, you want to have customer data that they be able to return to web applications in a very efficient and convenient way. And then in the 2000s, is the same changes to now. There's so many large-scale applications, and there's tons of data, and how can we have the ability to process a lot of data, and really a lot of data? How many of you think you work with a lot of data in your day-to-day job? Yeah, so a lot of you. And then really kind of like as it progresses, the problem becomes, sure, we now have the ability to process a lot of data, but then it is a very hard job. There's the different infrastructure you have to handle, there's failures that you have to deal with, and so really it becomes like, hey, how can we develop software to be able to conveniently access a lot of structured data without too much headache for the operational challenges. And then really now that we gotten pretty good at that, we want to really be able to conveniently access a lot of data in efficient and flexible manner. meaning you want to be able to use it in multiple systems. You want to be able to use it for different purposes, like building machine learning model, running analytical pipelines, and just access data in different patterns. And that's really the problems, or kind of like the challenges we have today, and how some of the open table format solutions are designed to solve. Yeah, so really before kind of like we talk about specific technical detail, like these are the problems we really want to think harder on. Like, is it convenient? How can I add more data through my system, and can I actually update data in my data layer without disrupting or inconvenience? Can I roll back to the previous version if I added some bad data or my data is corrupted? Can I actually go back and can recover my data in my data lake systems? And then when you think about, does it scale? Like, how much data can I put in it? Does it have a limit? And does it require infrastructure management of like a dedicated team, or does it just mostly manages itself without too much human intervention? And lastly, is it flexible and low cost? Because when we operate a lot of data at scale, this is very expensive. And really think about how we can reduce the costs and then also access it with different systems without having to make a specific copy of the data in that specific system. And that becomes challenges, mostly in terms of cost, but also operational challenges and delays and et cetera. Yeah, so this is really comes down to like the first and second generation of data lake technologies. Mostly 10 years ago, people used data lake with a layer like Hive data warehouse, where there's a lot of challenges because you can't really lack the critical functionalities like updates and deletes. And your query might return different results, depends on when you run it, and you can really support multiple writers to the data layer. And the second generation technology, like warehouses like Snowflake and BigQuery and some open source technologies, really fixing these challenges by combining the storage layer to handle more database-like features, so that we can actually pretend our data lake layer like a database, which is quite nice. Then the engineer can really focus on the business critical problems of like the data itself, rather than constantly having to fight through the challenges of working with the data. So yeah, so if you take a deeper look kind of like at the problem of like a data warehouse, so like in the most first generational pattern is that you have a lot of data, and then you kind of like have some logic, and then you transform and write it to the data warehouse. But the problem is, first you have a very complicated process, but also there's data inconsistency between your data warehouse layer and your operational data layer. So to address that challenge, essentially like now you kind of have like a two pipeline system where your data either goes through your data warehouse for specific use cases, or just some systems directly access the data lake layer. And so this is bad because you actually might get different results depending on how you access the data, and there's a lot of performance limitations on top of that. So the latest patterns that we're exploring and what we're leveraging at Foursquare is the Lakehouse platform, where you have a central metadata caching layers through the open table format that helps you to keep track of all the data without having to go through a data warehouse layer. And that just makes all the differences, because you have very strong consistency of like your organizational data, and every use cases like data science, reports, and machine learning goes through the exact same process using the exact same data. And also there's no delay in between the systems. So while we're comparing like a data warehouse and a data lake, these are really like key considerations like in making a decision. Like if you have multiple systems, does it have reliability concerns? Is there like a delay in the data warehouse because now there's extra step of processing that required to load the data into it? Does it support analytics supports? Like how can I write a very complex SQL query? So there's a limitation of like actually how big of that query can be, or how flexible the syntax can be to support those very advanced analytic use cases. And then lastly, the cost of ownership of this system is usually pretty expensive to operate a dedicated data warehouse, or even just using a warehouse system and using a data lake system on the country is usually like an order of magnitude lower in terms of efficiency and cost. Yeah, so open table formats is really kind of like the core of today's talk is like, how can we use this in a lakehouse architecture in Foursquare? So if you think about like what are really open table formats, it's really about three components. So there's the file layout, there's the API, and then there's the performance optimization. So file layout is really something in the file system, and you can really see it's actually quite simple under the hood. Essentially, in your file system in the old data lake model, you only have your files, and they're just individual files in different formats, in Parquet or JSON or CSV. But now, as you can see, there's an underscore delta log folder. So these are essentially transaction logs that helps you to keep track of individual data files and being able to communicate with the systems that you're accessing the data and tell the systems, hey, these are the important files. These are the files that's probably not relevant to your data at this point in time. And so it helps the system to process and making sure it can read all the data without having to have duplicates or have missing data files from the reader. And on top of that, really a Delta API adds this like flexibility on the access pattern. So different systems and different engineers usually have different preference in terms of what are the APIs they would like to use. And by providing those stable API in Scala, in Java, and Python for Delta, it allows different engineers or different teams who have familiarity with different patterns to be able to use the same data without having to rewrite their own framework to work with the data. And then the second part of optimization is that the entire open table format itself, it knows how to really handle things like compaction so that you don't have a lot of files in your file system. It knows how to properly skip data so that your computation becomes more efficient because you're not scanning data that's just irrelevant. And then there's some optimization support when you're writing the data so that it knows how to write the data the right way, so it's organizing it, and when you're trying to like access the data, it becomes more efficient. Yeah, and just want to share some of kind of like the lessons learned and integrations that we have using Delta Lake at Foursquare. So our largest Delta table is 50 terabytes of data, which supports multiple writers through the pipelines. We have a central data governance layer that the data platform team supports. Essentially handles data retention, data governance, and making sure data compliance with all of our data policies. And we have production integrations of different readers and writer, depends on the use case, from AWS EMR and EMR serverless. So that's the same things you guys learned about from earlier talk. And then lastly, we have analytical integrations from Databricks, which really helps users to access data in an ad hoc nature if they just want to learn and understand and drive insights from our data sets. Yeah, so really, this just sounds awesome and really promising. But what are some of the chains in the industry that really kind of like are still progressing from this point forward? So I think two things that we really notice is like two patterns. One is more auto tuning. That means the data storage layer really knows how to optimize the data for you and doesn't require the engineer spend more time to really try to manually tune their storage layout. like menu partitioning, for example. Those are more things that's kind of like being replaced by techniques like liquid clustering in Delta or hidden partitions in Iceberg. Essentially, it knows how to adjust based on some user configuration, but also based on the shapes and size of the data itself. And the other patterns we've been noticing is that just better support that makes the data system agnostic, meaning you can really access the data and work with it across different systems. So some of the examples here are Snowflake and BigQuery are the two larger systems that now both support open table formats. That means that you don't really have to decide and be worried about, hey, am I only accessing data in this particular system? Because it's just now it becomes much more flexible on how people access and work with data. And also you actually see a lot of like integration. We've seen like the data format world where Delta actually supports with Iceberg natively now. So even you have data stored in different formats, they kind of like just work nicely with each other. And you don't really have to choose like one format over another and have to be worried about kind of like, do I have to use a single format for everything? Yeah, that's really the talk. Thanks again, and I'm open to questions about how we use this and build this at Foursquare.
Any questions for Tony? Looks like all the questions went to Vlada in the previous talk. Anything? Oh, here is one.
Hey, hello, thanks. Yeah, just wanted to ask. I just wanted to ask about. You talked about data between the sectors in your company and stuff like that. Could you please share some more info about do you use architecture, for example, data mesh, or how do you track your data lineage between different kinds of data lakes and the stuff that you're doing? So,
yeah, so being able to manage data and tracking lineage is one of our priority at Foursquare. Currently, we have a data hub installation where it really helps to keep track of the data catalog and understand the lineage in between them, and we're actively working on more support using Data Hub and Acro Data, which is a vendor of Data Hub that help us to build our data catalog system to stay on top of the different data sets as well as the graph in how they're connected.
So you use this Delta Lake for storing your data, but which exact features do you use of Delta Lake?
For Delta Lake?
So the question was which exact features do we use? In Delta Lake.
So I would say Delta Lake itself is feature rich, so there's tons of features, but usually kind of like the things we kind of like things is critical is features like you can upsert, meaning you can add data to the table, and delete feature where we can actually delete data that's kind of like irrelevant, so we can delete it from our data lake. Yes, all these features are used at Foursquare. So a lot of use cases are, let's say, writing to the table or just deleting for data that's out of date. So usually we have to write custom systems that's very complex to handle those in the data lake. But now with the Delta API, those jobs becomes much easier and easier to manage from a operational perspective.
Thank you, Tony. This was great.
Thanks, guys.